What happens when a reaction occurs adiabatically? If we allow a system to go from reactants to products in a container which has a boundary such that no energy can come in or out of the system, then any energy given off when that reaction occurs has to stay in the system. Thus, if the reaction gives off energy, the temperature of the products will be larger than the temperature of the reactants. On the other hand, if the reaction requires energy, it's going to get that energy from the container and the surroundings, and the temperature of the products will be lower than the temperature of the reactants. And so we've not done this reaction at a constant temperature. Another way to look at this is that we've done two things at once. We've done a reaction and we've changed the temperature of the system. Whenever we do two things at once in thermodynamics, we can typically split the process up into two steps where we only do one thing at a time. If we split this up into a step where we do the reaction at a given temperature and then heat the products up to the final temperature, the result of step 1 and step 2 will be equal to the overall reaction that we were interested in the first place. The first step has a delta H that's simply equal to the delta H for the reaction at T1. The second step has a delta H that's equal to the heating from T1 to T2 of the products or everything that's left in the reaction container. And so we will need the heat capacity of the products or everything that's left in the container times dt. The overall delta H then is equal to the sum of these two steps. So it's equal to the delta H of the reaction at T1 plus the integral from T1 to T2 of the heat capacity for the products dt. Now, because we did the overall process adiabatically at constant pressure, we know that the overall delta H is equal to 0. If we treat the heat capacity of the products as constant and integrate, we can write that 0 is equal to the delta H of reaction at T1, the initial temperature, plus the heat capacity of the products times the change in temperature, or the opposite of the delta H of reaction at the initial temperature is equal to the heat capacity of the products times the change in temperature. Notice that if we know the heat capacity of the products and we measure the change in temperature, that allows us to calculate the delta H of reaction at the first temperature. Alternatively, if we know the delta H of reaction and the heat capacity of the products, we could calculate the final temperature of this reaction system. Solving for the final temperature, that gives us this equation.